Welcome. We're excited to have you here for the Building Secure Cloud Connected IoT Solutions with Windows 10 IoT Enterprise. Hi everyone, welcome to the IoT Show Deep Dive. Today we are going to be deep diving into building secure cloud-connected IoT solutions with Windows 10 IoT Enterprise. Today I have a bunch of folks joining me, which is pretty exciting. I have Michael from the Windows IoT team. Michael, do you want to do an intro on what you do here?
Yeah, hey, my name is Michael Bervell. I'm currently a program manager on the Windows IoT team. And, part of my job is to make sure that IoT Enterprise is really designed for our customers.
Thanks, Michael. I'm excited to have you. Michael's going to be going over what is Windows for IoT, what are the different products and solutions. He's also going to be going over, what is some of the feedback we've been getting from customers, from our different developers, from our partners about our different offerings. And this includes both Windows, IoT Core, and then Windows 10 IoT Enterprise. So I'm excited for him to deep dive into that feedback and what the changes are. He's also going to go over what is the some of the feedback, what we're doing with that, including, that lower BOM cost, so the bill of materials. What are we doing to provide, lower cost, low power embedded silicon? And I'm excited for him to showcase that. Next, we're going to have Amelia, who's joining us right now. Amelia, did you want to say hi?
Sure. Hi, everyone. I'm Amelia Casiola. I'm an intern on the Windows IoT team, and I'm working with a PE100A device to add some cool new features.
So Amelia's going to go over creating and deploying apps. I'm really thrilled to have her here because not only is she going to be showcasing Windows 10 Enterprise and kind of giving best practices there, but she's going to show that early support for ARM64, which this is your time to see it. It's a really early preview of it. Can't get your hands on it, so it's nice that she's going to be going over that demo with a real device. So I'm excited for Amelia to show that demo. And then next speaker that we have is Henry. He's from Dover Viewing Solutions. Hi, Henry.
Hi, I'm Henry Figline. I'm the Senior Director of Global Platform Architecture and Automation. My team defines the next generation platform for all of those fueling dispensers that you use every single day.
Thanks, Henry. What's nice with having Henry here is actually showing a real use case using Windows 10 IoT Enterprise. This is actually a scenario that I've used in some of my past virtual events because it really puts it into perspective. And so we'll talk about what that scenario is, but just a sneak peek, it's all about using Windows 10 IoT Enterprise, Azure IoT Hub, Azure Stream Analytics to build a solution for fueling pumps. So you can imagine if you go to a gas station and you are pumping your gas, there's going to be a screen and it kind of has a personalized experience for you. So Henry's going to go ahead and show that and how he built with Windows 10 IoT Enterprise. So let's go ahead and get started. My name is Pamela Cortez. I'm on the Azure IoT team. I focus on creating technical content and taking all of your feedback to improve the products that we have here on Windows, on the Azure IoT team. And then I will be on chat, live Q&A that's happening at this moment. And so if you're watching on demand, deep dives, they are live events. However, don't worry if you can't get in your live questions because we do have resources and communities for you to check out after the event. So if you're watching on demand, we'll tell you how to reach us after. All right, so Michael, do you want to go ahead and kind of talk about, what is the Windows, offerings for when it comes to IoT and where are we heading?
Awesome. Thanks again for having me, Pamela. Yeah, Windows for IoT is we have so many different offerings, and all of them offer 10 years of OS support, security, and manageability. What we're going to be talking about today is Windows 10 IoT Enterprise, but I do want to highlight that we also have other services, such as Windows 10 IoT Core and Services, Windows Server IoT 2019, and SQL Server IoT 2019. Here at Microsoft, we believe that Windows for IoT is the ideal Windows edition for fixed-purpose devices. It's the type of platform where you can build point-of-sale systems, vending machines, digital signs, industrial human-machine interfaces, and more. The main offerings, like I mentioned, are IoT Core, and we also have IoT Core Services, which offers 10 years of support, especially for small footprint devices that are low-end hardware, things like ARM64 and ARM32. We also have IoT Enterprise, or Windows 10 IoT Enterprise, which we've been offering since Windows 10's 2015 launch. We've had 3 LTSE, long-term service editions, releases, and also full functionality for Windows on these devices. We think that Windows IoT Enterprise also offers the entire stack, meaning full video and media capabilities, security, and everything that you hear about a little bit later from Henry as he talks about Dover. We also have IoT Server, which we describe as when you need the big beefy lockdown with a server device. You can imagine use cases such as huge edge computing workloads, and it's licensed the same way as IoT, but what I want to focus on here, like I mentioned, is Windows 10 IoT Enterprise. So if we take a look at the next slide that we have, there's a couple questions that people tend to ask. Why am I using Windows for IoT? Why should I even build with Windows? And there are 3 core reasons. It's smart. This is an ecosystem of compatible software that billions of active devices are using every single day. So if you build your IoT device with Windows, you get this smart, secure, and fast system. It's also secure in the sense that we have a full-time team of security experts who are always updating Windows. So that, paired with 10 years of support, really helps you to make sure that you're always up to date with security. It's especially important nowadays. And finally, it's very fast. It helps you as a consumer and you as a developer get to market even quicker. It's a turnkey solution. Your development time is reduced because you have this operating system that's managed by Microsoft. It helps reduce cycles and your time to market. And when you consider the hidden costs of building an OS, for instance, open source platforms that might require additional maintenance, Microsoft takes on all of that, which is why Windows for IoT, we believe, is the ideal solution. Now, moving on to the next slide, we're constantly talking with customers to see how we can improve Windows IoT, both Windows IoT Core and Windows IoT Enterprise. And some of the things that we've heard in talking to customers is, well, I want to make sure that I can run all of my code on something like IoT Core, or I want to have more broad support on my silicon, or even more than that, how can I support Azure IoT Edge? And on the same exact vein, in Windows 10 IoT Enterprise, we've heard complaints and really suggestions that we should offer the OS image as a smaller size because it's too big, or really, again, the idea of having low power, low cost embedded devices and embedded silicon. So we've listened to all of our customers and came up with this roadmap that I'll share on the next slide. But broadly speaking, we're super excited to hear from our customers about what they want and what they want to do for improvements.
Yeah, and Michael, one of the biggest things I was hearing from customers and fellow developers, especially at the local or the last build event, there was a big question of support for Raspberry Pi. I figured I would slip that in just because I think anytime that we talk about Microsoft IoT and Windows gets brought up, I know there's always that question. I get pinged on Raspberry Pi. Do you have an answer that we could share?
Yeah, well, we have Windows 10 IoT Core open source BSPs for Raspberry Pi 2, Raspberry Pi 3, the Raspberry Pi 3 compute module, and Raspberry Pi 3B Plus. And on the resources slide, we'll share a link that you can go to get access to those BSPs for your personal use. If you're interested in expanding and supporting for other types of Raspberry Pi, specifically Raspberry Pi 3B Plus and or Raspberry Pi 4, we really do want to invite you and the rest of the open source community to help us in our open source Raspberry Pi IoT Core repo. We're constantly monitoring GitHub and Stack Overflow and are super happy to help with community development. Additionally, I do want to remind everyone that we offer 10 years of support with IoT Core services, and also on Windows 10 IoT Enterprise, we also offer 10 years of support. So you may want to use open source BSPs for Raspberry Pi, and you can also use the commercial BSPs that are supported by Intel and Qualcomm. Or most recently, NXP also released a BSP. So there's a lot of options out there for the hobbyist or even the more advanced Raspberry Pi developer.
Yeah, I know a lot of developers, even if they're not a hobbyist, they kind of like just doing a PLC just to test out the tech itself on a Raspberry Pi. So thank you so much for giving that answer. It's always one of those questions that we get, and the team, we don't know how to answer it because we don't have folks like you in the room telling folks what the answer is from the Windows IoT side. Other thing that I notice we get a lot of questions about is about Windows IoT Core, and I love that you're bringing up the slide that's talking about what's the roadmap for that. And I know there's a lot of people asking about what are we thinking about? What's next really for Windows IoT Core? So definitely excited for you to talk about that future platform conversion of the two.
Yeah, it's a great transition, Pamela. So thank you so much. And also thank you to our community, because we really do want feedback. That's how we make IoT Core and IoT Enterprise better and how we decide where to move next. But I'm super excited about this future platform conversion and convergence. So after talking with all these customers and hearing from them, we decided that we wanted to take the best parts of Windows IoT Core and merge it with the best parts of Windows IoT Enterprise to essentially combine these into the next version of Windows IoT, the Windows IoT Enterprise LTSE. Of course, like every other long-term servicing release, it's going to have 10 years of support. And some of the customer benefits is it's really going to be one stable platform that meets all of your needs, meaning we're hoping that it's going to be a reduced size. It's going to leverage existing software, so you don't have to rewrite all of your software. We want to have better support for IoT Edge, and we want to run Linux on Windows in containers. There's actually a video that was released by Olivier and Terry Warwick on our YouTube channel that you can check out that gives a little bit more detail about Linux workloads in containers. And we also want to have low cost and low power embedded silicon. There are so many things that we're excited about releasing with this IoT Enterprise LTSE. But really the main job is to really make your job as a developer easier and to help you through these types of solutions. On the next slide, you can I want to do a little bit of a deep dive into the bill of materials costs and ways that we're looking specifically to lower these. We have the Intel processors and the AMD processors on x86 and x64. And we definitely want to also enable the NXP IMX8M mini board, which is ARM64. And IoT Enterprise, this hasn't been enabled before. And during our demo, we're actually going to show some of the cool features that you can do with this ARM64 device using our operating system. But we're super excited because it'll really lower the bill of materials for our end users and for our customers. I do want to highlight, especially on the next slide, one board in particular, which is the ASUS IMX8 IMA board. It's about the size of a Raspberry Pi. I'm sure when you see Amelia's setup, you'll see just how small it is and how nimble it is. But it has the ability to run Windows 10 IoT Enterprises edition, the next edition that we're releasing. And as an added bonus, it also runs the in-market version of IoT Core. So we're pretty excited about that. It's also available in off-the-shelf packaging as the PE100A and is ready to deploy almost immediately. So you can go to the webpage that we listed at the top here, iot.asus.com, to get all of the details, because we really want you to get your hands on it and to be able to develop even better products. And so the final slide that I want to share before I pass it off to Amelia and back to Pamela is really the reduced OS footprint, because this is a huge thing that we're excited about and that a lot of our customers are excited about. So obviously we have this wonderful silicon that we got from partnering with ASUS, but also internally we're working to reduce the size of the OS footprint. And our target for this release is 16 gigs of storage and 16 gigs of RAM. We've also heard from customers that they really want to fit the full Windows stack on a smaller part of the silicon, and we're hoping to enable that as well with this new LTSC release. So with that, I'll pass it back to you, Pamela. Thank you so much for listening to me babble on, but we really love talking to customers and sharing with customers.
And I love that the team is taking that feedback and making those changes. And I wanted to ask you, so when you're talking about the conversion, does that mean that Windows IoT Core is dead, or does it has that maybe 10-year support and then it retires? Or I'm interested in what our statement is there.
Yeah, so if you've gotten IoT Core before, let's say you got it in 2019, we'll still honor the commitment of 10 years of support up until 2029. But we're super excited about the IoT Enterprise LTSC because it takes all the goodness of Core and adds this additional goodness of IoT Enterprise that you normally wouldn't have had. So we think it's actually it's a better solution for a lot of use cases that we want to transition customers to get to.
And you mentioned the long-term service channel. How often are those updates provided? How frequently can customers be able to get those updates?
Yeah, so LTSCs are released approximately once every 3 years, but each LTSC comes with 10 years of support and servicing. There are certain devices that we think tend to fit better for traditional LTSCs, things like medical systems, industrial process controllers, air traffic controller devices, and a few others. Just because since they're not updated, since we don't release LTSCs as frequently, it's a different kind of class of device. But we're super excited about this convergence because we really do think that it'll enable more devices to be running on Windows and to get the fast, secure, and safe benefits that Windows offers.
That's amazing. And I really appreciate you coming here and giving that question that has been asked a lot about Core. So I think that helps us, especially when we talk to the developer community and when we're getting feedback, provide that insight. And then my last question before we jump into Amelia's demo is if you are going, if you want to upgrade from like Windows 10 Enterprise, the long-term service channel, to let's say Windows 10 Enterprise, how would you do that? And is that an option?
Yeah, so technically, since LTSC is its own SKU, an upgrade would require a new license. So we'll have resources at the end of this slide deck where you can go to reach out to distributors and contact us directly through, if you want to comment on the YouTube channel, or I think there's also the blog post that you can comment on. And we're constantly monitoring those to make sure that we support our community. But you will have to get an upgrade since it's a different license. It's its own SKU.
Okay, thank you so much. And we'll see you at the end. So really appreciate you answering all of those questions and giving those insights. So Amelia, we're really looking forward to this technical walkthrough, especially seeing the early preview of the ARM64 support.
Awesome. Thanks, Pamela. And thanks for that intro, Michael. So as Michael mentioned earlier, one of the new up-and-coming things for Windows 10 IoT Enterprise is support for ARM64. So what I'm going to be doing today is doing an overview of how to create a universal Windows application and run that on an IoT Enterprise device. And just as a sneak peek, we're going to be doing that with the PE100A that Michael mentioned earlier. So what I'm going to be going through is explaining in high level the process you would take to create and load your IoT Enterprise image onto your device, and then go through a couple setup steps that you'll need to do in order to remote debug from Visual Studios. And then I'm actually going to do a demo of how to create that application in Visual Studios and then deploy that over to your device. So first things first, you're going to need to create your IoT Enterprise image. So these are a couple high-level steps. There's a lot more information in the labs at aka.ms/IoT Enterprise Labs, but these are steps you could take no matter which board you're trying to load with this image. So first of all, what you're going to need to do is create that installation image. Normally, it'll be taken from an ISO file, and then it'll be loaded to an SD or USB and that will be your setup image. Then you're going to be wanting to add your features on demand, drivers, languages, OEM software. You can then configure your policy settings through the group policy editor. And then finally, once you're all done with your image, you like the way it works, then you would prepare it for deployment and then capture that to a loadable WIM or FFU file. So again, just a super high level description, but if you head to that link, it'll give you steps on how to actually perform each of those steps. Something else I did want to mention is a couple features our customers really like to use. So there's device lockdown features, such as the shell launcher and assigned access. And you can use these features to set up your device in a mode called kiosk mode. So what shell launcher is, it allows you to set up a non-UWP application as your system shell. So that means that when an application exits, you can actually do custom actions based on that exit code. For example, you could just restart that application, or you could shut down the device, restart the device, or anything like that. Assigned access is really similar, but you can use a UWP application for your system shell. And again, you can use this to automatically restart that application when it's closed, and that way you're keeping your user in their intended experience. So using those device lockdown features, what you can do is set up a device in kiosk mode. The two pictures you'll see at the bottom of the slide there, the first one would be a single app kiosk. So in this case, you just have one single application, a UWP application running above the lock screen. So that's all users can see and interact with. In the second picture, there's a multi-app kiosk where certain users are given privileges to see different applications. So you would see a custom start depending on the user, and all you would see was the applications that they're allowed to use. So those are just some ideas in order to set up the device the way you'd like to. So now, assuming that you have a Windows IoT Enterprise image running on a device, a couple things have to be enabled. The first thing is embedded mode. So embedded mode is really important for IoT projects because it allows you to run applications in the background, and it allows you to access hardware interfaces like GPIO. So in order to do this, we're going to go onto our enterprise device, and we're going to create a new advanced provisioning project from our Windows Imaging and Configuration Designer. So in the first picture there, you can see you just can name it, allow embedded mode, hit next. In the next pane, in screenshot B, just search for embedded mode, click allow embedded mode, and then export that package. So that you'll end up with a PPKG file. And you actually can do this process on your enterprise device or on your host PC. If you do this process on your host PC, you're just going to want to copy over that file that's created over to your enterprise device. And then when you double click on that package, it'll set up embedded mode for you. Next thing we're going to want to do is enable developer mode. You're going to want to do this on your host PC and then on your enterprise device as well. So if you just open your developer settings panel, as you can see in picture number A, and then you want to enable developer mode and turn device discovery on. That's really important to do on the enterprise device for device discovery so that the host PC can find the enterprise device in order to remote deploy those applications. Now, just a couple more things to do before we start creating an application. You're going to want to install and run Visual Studio's remote tools on your IoT Enterprise device. So we have a link here, aka.ms/install remote tools, and there you can get the version of remote tools that corresponds to the version of Visual Studios that you're running on your developing PC. So you can see in this picture here what it should look like when you launch the remote debugger, and that's what mine looks like right now. And then last step before we make apps, you just want to be able to connect your device to your host PC. And you can do that either directly through an Ethernet cable, USB, or over Wi-Fi. I do recommend doing the direct connection through USB or Ethernet cable just so that your app can deploy and develop faster. So once all that's done, this is what my setup looks like. So you can see in the center of the picture here, I have my device, which is running ARM64. And it's connected directly through this Ethernet cable to my docking station, which is plugged into my Surface. So that creates a direct connection between those two devices. And then I just have a couple peripherals plugged into my device. I have my monitor, my keyboard, and my mouse. So now let's open Visual Studios and give you guys a little demo. So when you're first creating a universal Windows platform application, you're just going to want to go to File, New, Project over here. And there's actually some great templates which are already here. So if we just search for Universal Windows, you can see this first template that comes up here. It'll have everything you need to make your first app. So we hit next there, name your app whatever you want, and then you'd hit create down here. Now I've already done that, so I will just show you the files that it generated. Your template should have all the same files that I have open on the right here. The ones we're going to focus on today will just be your main page XAML file and then your main page C# file. So I've opened the XAML file right here, And when the template is first generated, it should just have an empty grid here. Now, what this is going to be, it's going to show your layout and your UI for your application. So I've gone ahead and added a panel with a couple elements in it. I added a text box, and then I added a button. So we can hop in here, and you can see the design of what those elements look like. Now, it's kind of boring because these don't actually do anything. So we're going to go ahead and change this so that when you click on the button, something actually happens. So a cool thing about Visual Studios is that if you double click on a clickable element, this function will actually be generated for you. So now this will be called whenever I click on the button. So we want to add some code in here so that this function does something. What I want to do is make it so that some text shows up in this text box when I click on the button. So if we go back to the code, we can see that this text box is called hello message. So we can just reference it by its name in the C# file. So I'm going to go ahead and do that. And we're going to change the text field. And we're going to just set it to a nice simple string. Windows 10 IoT Enterprise. Now when we click that button, this string should show up. So what's really cool about these universal Windows platform applications is they can run on a whole bunch of different platforms. So my local machine is a 64-bit machine. And if I select 64-bit from this dropdown here, I can actually deploy this application and test it out locally, see that everything works the way I like. So I'm going to go ahead and do that. Just hit this play button here, and it'll start to deploy. There's various output that you can see at the bottom here from the build order, debug, deployment, whatever you need to look at in that certain case. And it should just take a couple minutes to pop up on the screen here. All right, so here's our application. When we click our button, it shows a string. So if we like that, we like the look of that, what we can do is actually, without even changing any of the code, we can deploy this straight to our ARM64 device. So in order to do that, we open the Solution Platforms dropdown again, and we pick ARM64. What you can do is, since I've already connected to this remote machine before, it recognizes it. But otherwise, in this drop down here, you would just select the bottom tab, and this will open your configurations file. And in this configurations file, under debug, you can see the start options. If you hit find, it'll detect any direct connections or other devices on the Wi-Fi network that you can remote deploy to. So in this case, we can see my direct connection here to my board. So I'll just select that one. Now we can go ahead and deploy it. Now deploying to this remote device will take a little bit longer just because we have to actually build everything and then copy all those files over to that remote device. So let's just wait around 2 minutes while it deploys, and we'll circle back when it's done that.
Amelia, while we're waiting for that to happen, what are some common setup issues you see that folks run into when they're doing debugging?
Yeah, that's a good question. There's actually a couple issues that I definitely run into. One of them is that if you don't have your device plugged into your host PC directly, if you're using Wi-Fi, the deployment can actually fail just because the connection might be too slow. So if you're running into that issue, things are struggling to deploy, that could be why. Another issue is if you have a different version of debugging tools than the version of Visual Studios, because those won't be compatible. So you got to make sure, for example, I have debugging tools 2019 and Visual Studios 2019 running. And then the last thing that I think is pretty common to run into is if the authorization modes for your debugging tools and then your host PC are different, and they won't be compatible either. So in when I clicked in this drop down right here and I selected my remote device, it had Windows as the authorization mode, and same with on my debugging tools. So if those aren't the same, that will also cause an issue. So those are a couple of things to look at.
And do you have that tooling support for Windows for both VS Code and Visual Studio? Is that going to be the same experience when you're building and creating these apps for Windows IoT Enterprise or Windows 10 IoT Enterprise?
Yeah, exactly the way I'm doing it here can be done for any Windows 10 IoT Enterprise device.
Okay, so any of the IDEs, Code, Visual
Studio, not VS Code, just to be clear. The one I'm using here is Visual Studios. I know the names are similar, but this is how you can do the remote deployment process. You can do the coding in Visual Studios Code, but the deployment has to be through Visual Studios itself.
That's one of the top questions we get a lot is the experience. Should you be using Visual Studio versus VS Code? Will you have the same support level for both IDEs?
Yeah, I would definitely say if you want to be remote debugging and deploying, doing it all through Visual Studios is the best way to do it. If you're just coding something, exporting it elsewhere, then Visual Studios Code is perfect for that too. So as you can see, our app is loaded here on our device, and we have the same functionality going on with the words showing up. Another thing I wanted to point out about having the direct connection between your device and your Visual Studios is that you can actually hot reload your application. As you can see at the top of the screen here, it says hot reload available. So what that means is that you can actually go in and tweak your UI, and before you even save the file, those changes will be sent over to your device. So for example, if I didn't like the background color, I thought that orange was too bright, I could go in here, edit background, change it to a different color. And we can see that literally straight away, less than a second, the color has changed in our app. So that's a great way to do some final tweaks to our UI when it's actually running on our device. And so that's it for the demo. Super simple app that we just deployed and debugged, and hopefully you all learned something from that.
Yes, and I love when demo day works.
Yes, me too. Best feeling.
It's a great feeling. And then Amelia, I'm looking at your project, and it looks like you have XAML files and then C# file. What is the main differences between the two in this particular application?
Yeah, great question. So the XAML files are there for the layout and the UI of your application, and then the C# files are there for the behavior. So .NET apps are actually made this way so that you can separate the behavior and the designer code, and then that work can be parallelized really easily. So it just helps you get those apps created faster together.
Okay, wonderful. Well, thank you so much for showing this demo, for giving us that sneak peek of the ARM64 support. I was really, really excited to see it. It's the first time I've seen it in person. So thank you so much for showing that. And it's always a great feeling when the demo works.
Absolutely.
When it's early preview. All right, so let's go ahead and jump into a real world scenario with Dover Viewing Solutions. So we have Henry here. He's one of the senior directors. And so Henry, I'm really interested in hearing how you took Windows 10 IoT Enterprise, Azure IoT Hub, Azure Stream Analytics, and made a really awesome application solution where you're personalizing gas station pumps. I hope it's going to make the experience of pumping gas a lot more better, a lot more pleasurable, I guess, as much as you can pumping gas.
Well, thank you, Pamela. So what we have done at Dover Fueling Solutions is we have begun to create what we're calling the digital transformation for an industry that is not as far along in embracing the IoT world as other industries. We began by creating a number of intelligent cloud applications. We used the service fabric in order to build up an actor model type environment for analyzing data that's coming off of our dispensers. We use the IoT Hub for actually connecting to the environment and collecting that data. And then we began to look and say, hey, this is a nice first step, but it really only takes us a little step down the way. One of our biggest problems is the industry that we're in is really not one that likes to make major investments in order to leverage new technologies. So in our past iterations, the device that we were using in order to connect to our cloud environment was one that we had repurposed for connecting out to the dispensers and controlling the dispensers, something called a forecourt controller. We have a price point that is way too high for just creating an IoT environment. And so we were able to go and look and create a new intelligent edge environment based off of a really low-cost device, much like what Amelia was showing before. We incorporated a lot of the security features into it that are inherent to IoT runtime. And of course, we're hooking directly to the IoT Hub environment. And we've added some intelligent provisioning on top of that allows us to not only provision monitoring tools like we were using in the past, but also the tools that Pamela was talking about for actually creating a personalized environment on the dispensers. Now, that was a great first step that allowed us to reduce our costs, that allowed us to take advantage of the Windows IoT platform and the security that's involved with the Windows IoT platform. But our old dispensers really didn't have the capabilities of taking advantage of the fact that now we have, all of this capability to connect to the cloud. So we then took the same concepts and the same IoT enterprise platform that we had built on the intelligent edge, and we moved it out to the dispenser. And we said, okay, this is great, but a little dinky screen that barely has anything on it is not so good. And we had a number of different screens that were on there. We said, why don't we bring the dispenser into today's world? And we put a 27-inch display on the dispenser, and we're running Windows IoT Enterprise to drive the visualization that you see on the dispenser. We created a number of different apps that are actually AngularJS apps that allow you to show the data that you're getting. But as a core, we use the IoT runtime system to connect up to the fueling components, to connect up to the user interface, to connect up to the cloud, in order to be able to truly provide a new and exciting experience for our customers. So the way that we did that is we actually went to an IoT edge-based design. We created multiple web apps that you see here on the left, one for showing what's happening with the actual pumping of the fuel, one for handling any secure prompts that we may have to ask you about your credit card itself or your debit card. We had a customer app which was responsible for driving the customer experience. And part of that customer experience is actually creating a dynamic new UI that incorporates media, that incorporates imaging, that in the future will incorporate things like facial recognition and voice recognition. All of those can be built into the web app or into the IoT runtime system. On the IoT runtime system, obviously, we were taking advantage of the fact that this is a highly secure platform. We're using the launcher capability to only launch these web apps as the system is starting. We have a secure platform for connecting up to our secure payment system that is actually in the keypad that you see on the dispenser. And we have the capability of connecting directly from IoT Edge to our IoT Hub platform, or in cases where perhaps the bandwidth at the particular location is bad, we can consolidate that in that edge box that I showed you before. On the IoT Edge platform, we took that same exact build, just like Amelia was talking about creating individual builds that you could that you could run on different platforms. We took that exact same build that we were running on the display board, and we moved it over to the IoT Edge board. And we created the same IoT Edge runtime environment, which can connect to our cloud, but it can also connect to payment hosts and loyalty hosts for driving the communication and driving the transaction, creating a much more robust user experience model, which allows us to understand who is using the dispenser and what sorts of things are relevant for that particular user at that particular dispenser. We can tailor advertisements. Obviously, not everyone wants to have tailored advertisements, but we have the capability of doing that. We can tailor the actual experience, so we can skip steps that normally you would have to go through on every single dispenser. Insert your loyalty card, insert your payment card. Do you want a car wash? Do you want to buy this additive? All of that can be pre-configured in a user profile and downloaded directly onto the Edge box, so that when you go to the next service station, you'll get that exact same experience where you're able to skip steps as well. And that's regardless of which brand of fuel that particular service station is listed with. We have the capability, again, of using the key management modules for managing the keys that we're using to connect up to the cloud, to connect with the payment terminal, to connect with the point of sale system in the store. And finally, we have the capability of enhancing the prompting based on who you are as an individual. It's really simple things which allow people to get a more comfortable experience out of this fueling experience where you really don't have any choices in it. You're held for that 4 to 5 minutes, not able to do anything at all. Well, we can now enhance that with some sort of prompting. We can also enhance it with media, and we can offer you things to make your experience be more enjoyable. So, for example, we're putting the ability to have things like Candy Crush run during fueling, so that you can play Candy Crush. Yes. Or something that one of our hackathons had was, hey, why don't we create an exercise program for you to do while you're in the middle of fueling, because maybe you don't get much of a chance to move around so much. So using the camera that is built into the dispenser, we can look and see whether or not you're exercising, and really create a crowdsourcing, enjoyment experience between multiple users of the platform.
I love those examples you gave, Henry. Because I can imagine with Candy Crush, though, you might have people staying a little too long, so you might have people backed up to get to the pump.
It is true. It's something that we've talked about, but if you only offer the first level, it's not so bad.
There you go. And then the fitness one, though, if they're advertising like a slushie or something like that, and donuts in the store, doing a couple squats before you go pick up your gas station items, I think would be amazing.
Exactly. It at least gives you the ability to burn off those calories before you put them back on.
Exactly. Well, I would love to see this demo in action.
So yes. So I'm going to play this video. Hopefully it's not going to have any noise going on, but here you can see the dispenser in action. This is actually up in Belton, Texas. This is installed. It is being used in Belton, Texas. Up at the top, you see that it's showing you the sales volume display. This is how many gallons of fuel that you pumped for how much you paid. In the middle there, you have an area that we call our Customer Experience Center. This is where you have the ability to play media, to play the Candy Crush, etc., while you're in a fueling state. At the bottom, you're going to show the various fuel grades that are available. In this particular video, you're only seeing what we're calling the idle screen. The idle screen is basically waiting for someone to come up and use the dispenser. The media is going to be less around advertising and more around trying to get you to come to this particular dispenser. Once the camera recognizes that someone is standing in front of the dispenser, it will now take them through the customer experience, which I will now show a video. This is broken up a little bit, and it's not showing everything because we did take out some of the pieces where the person was actually typing in their credit card, etc., or typing in their credit card information. You're seeing the idle screen, and it is actually playing the media, trying to get someone to come up to the screen. Once you see here in the corner is the camera where it's actually looking for someone coming in to view, to actually do something with the dispenser. Now you can see it asks the customer whether or not the card that they inserted was a debit card. If it's a debit card, then the customer can answer yes and type in their PIN information. There you see it's authorizing the transaction. Again, all of these are individual applications, including that welcome valued customer. That's its own application where we can add and subtract and multiply in order to give the customer a much more customized experience. You'll see the branding content down at the bottom for this particular station, and now the customer is being prompted to actually lift the nozzle and choose the grade of fuel that they want to actually put into their car. Once the grade of fuel is chosen, you'll see the grade show up in the upper right-hand corner. The user will pick up the nozzle, begin to insert fuel into the tank. You'll see the sales volume then run all by itself, and the user will also now get a series of advertisements, which could include a coupon down at the bottom, along with the media that was chosen to display during the fueling transaction. Once the fueling transaction has been completed, the user hangs up the hose. They're prompted to print their receipt. Once the receipt has been printed and the transaction is completed, then the user can go on. Now, the important part for this is not the actual running of the transaction. It is that we're using the Windows IoT platform in order to drive not only what's going on the screen, but also the individual hardware components that you see associated with the dispenser. Up at the top right-hand corner, you see the camera that's being run by Windows IoT Enterprise. The card reader and the secure secure pin pad, those are all being not controlled by Windows Enterprise, but at least prompted by Windows Enterprise. And then finally, you have the contactless card reader, so that we can begin to do things with Apple Pay and Samsung Pay and everything else. That allows us to get to the point where this dispenser can, in the future, become a completely contactless dispenser, with the exception, obviously, of having to lift the nozzle and put the fuel inside of your dispenser. The way that we're going to be doing that is by adding IoT Edge modules to the platform that's actually running that large display. The IoT Edge modules could be things such as a module to go off to Azure Cognitive Services and do text-to-speech or speech-to-text to allow the consumer to drive the transaction completely and totally without touching the screen. This is a giant touch screen right now. Obviously, COVID has changed the way that we're looking at some of these things. And this is one of the things that we're going to be diving into more and more is how do we take advantage using the IoT runtime environment on Windows 10 IoT Enterprise of the cognitive services that are available in Azure in order to take this to the next level, whether it is making it completely internationalized, where we could do multi-language, have the user choose the language that they want to have, whether it is, again, driven by speech, or even in the future, maybe even driven by gestures or facial recognition completely and totally, where all you have to do is walk up to the dispenser, it recognizes who you are, you lift the handle, it's going to pay with the appropriate card that you want to have associated.
Thanks, Henry, for showcasing that demo. I know you mentioned a lot with IoT Edge. So for folks who are viewing and haven't worked with IoT Edge before, in the description and in chat, I'm going to add some resources for you to check out if you're curious about working with the IoT Edge runtime that we offer. If you want to take some of those cloud workloads and put it on the edge, I'll share some resources. So I'm very interested, Henry, on why you chose Windows as your main operating system. And then has your team always been like a Windows shop, or have you experimented with playing with some other OSs as well?
Sure. So actually, the original dispensers that you see out in the field today are Windows CE driven dispensers. Yeah. When we began the project to create this 27-inch display, we actually were trying to make it work on an IMX platform running Linux. Mm-hmm. Unfortunately, the video that you see with all of the different pieces really was just too much for both the IMX platform and the Linux platform to be able to take advantage of. We switched over to an Intel platform running Windows IoT Enterprise, and we saw an immediate advantage. Where we were using 90% of the CPU previously, we were down at 20% of the CPU, and it was yawning when we were running 2 to 3 videos simultaneously. So you can imagine having that sales volume display where those numbers are going up every second. That takes a lot of CPU. And so the Windows IoT Enterprise just made it so much easier for us. Plus, then integrating in the cognitive services and everything else that we were doing, we were basically able to do a demonstrative facial recognition capability for the North American Convenience Store show last year. I think I wrote the program in about a week.
Oh,
wow.
Yeah, my next question was about to be how long it took for this all to get up. Like, what was the uptime for it? It sounds like a week, but what were some of the other considerations that you made?
Actually, it wasn't a week. I wish. No, so it has taken us about 1.5 years to get to the point where we're now actually having dispensers go out to the field. Now, obviously, a lot of that was hardware engineering. How do you build put a 27-inch display out there, etc. But it was also the whole back and forth when we went to the Linux platform, and while we were programming in C#.NET, it still meant when we changed to the Windows platform that we probably did some things in a Linux manner that we really didn't make as generic as it should have been. So once we switched over to IoT Edge and began to move things along, it went much quicker. I'd say we probably have 2 years worth of development on this platform under our belts.
Yeah, I mean, there's a lot of kind of research that's shown that IoT solutions sometimes takes from going from that proof of concept stage to production a year or, 1.5 years. It does really, especially if you're creating a new device, like you said, Henry, and moving forward on that, there's so many stages on kind of building it. But I'm glad at least for that one portion of the solution, it was a week of development.
Well, just to let you know, we made that switch from Linux to Windows IoT Enterprise October of last year. So from October until May, when we actually installed the ones that you see in the video, was how long it took us to switch from Linux over to Windows IoT Enterprise.
Oh, wow. And I know you mentioned with COVID-19 how the team is, thinking about how you can use cognitive services. I know you mentioned like text to speech and things like that, and that voice recognition. I'm just interested in if you could share more information on how the team is thinking about creating that experience where people aren't touching the screens or just keeping mindful of what's going on in the world right now.
Yeah, so what we are looking at is where we can make what we call the frictionless retail experience. Mm-hmm. Our goal is to get to the point where you really don't even have to interact with a payment system whatsoever. It's able to recognize who you are based on something about you, something that you have and something that you know. Mm-hmm. Standard security practices, right? And then allow you to move around and continue your shopping experience. So you would start your shopping experience at the dispenser, and then maybe move inside the store and pick up your Let's Go Healthy, your wheatgrass and your avocado wrap without actually having to interact with another payment terminal inside the store. That way you feel much more, what's the right word for it? You feel much more comfortable with the fact that you are getting what you need without having to interact with too many possible places where you could contract the virus.
Yeah, and so I know I did a little bit of research into this industry, and I think it's really interesting, actually very large, right? There are 700,000 fueling stations globally, and almost 2.6 million fuel pump dispensers. And of course, part of Dover's hope is to get into as many of these fueling pump dispensers as possible. How are your end customers feeling about Windows, and how do they react to kind of this new technology shift from a local aspect?
So all I can say is that the number of inquiries that we have had about moving to this 27-inch display, knowing right now that the customer would actually have to go out and physically take out the dispenser that they have on the island today and put in a new dispenser with this 27-inch display, is absolutely amazing. The distribution channel, which is our normal channel for selling to the convenience stores, is coming to us and saying, we have to have this now. And we are literally ending up a beta stage right now and moving into full production. And we can imagine that we could easily be on the order of 4,000 to 5,000 units by the end of the first quarter next year.
Wow.
Yeah, and I know traditionally, I think I saw a statistic that close to 90% of pump issues or failures are reported by motorists. So how is this technology helping to alleviate and stop kind of that issue of pump failure?
So that's the nice thing about being directly connected to between the dispenser and the IoT hub, is we're actually getting the failures that are happening as they're happening. And so we're able to report it to our cloud environment, and we're able to resolve probably 50% of those without any sort of other intervention. Where we're moving towards is what we call predictive maintenance, where we're actually going to be looking at the individual devices within dispenser, looking at what sort of readings that we're getting as far as telemetry is concerned from those devices, and predicting when we may actually have to change one of those devices out. Simple example is something like a fuel filter, right? So a fuel filter is something that you need to change on a relatively regular basis. We have people that go out and maintain these dispensers probably every 2 months to make sure that there are no issues that the customer is seeing. Well, if we're now able to tie the fact that we are seeing fueling slowing down ever so slightly, hopefully, with the next time that person is going out to help maintain those dispensers, we can have them change out that fuel filter while they're at the regular maintenance, versus having some sort of emergency maintenance because a customer complained about the speed of fueling.
Yeah. And ideally, that would even lower costs, being able to do it, in advance rather than when the system fails.
Absolutely. Absolutely.
So I'm interested, since you're using IoT at runtime, are you mostly doing everything, running everything locally? Like, how often are you picking up information? I know you just mentioned you're doing predictive maintenance. Are you running AI models on the edge to do the predictive maintenance before you ping up to Azure important information to then go ahead and contact, let's say, your service worker?
So actually, it's a combination of two things. So we have a number of different products. One of them is our wet stock product, for example. Our wet stock product is doing an analysis of things like fuel loss. So how much fuel was taken out of the tank versus how much fuel was put into a car. If there's a major amount of fuel loss, you don't want to wait for it to get up to the cloud, do some streaming analytics on it, and then figure out that you're having fuel loss and go back down to the site. since we have the edge device there that is actually doing some of these calculations, it's able to actually perform the notifications directly, get to the clerk and say, hey, we need to shut off this particular dispenser because it has a fuel leak somewhere inside. Obviously, we're balancing that. One of the things is that we're doing a proof of concept on, and some of it you'll see in a demo that we are showing at Insight, is the concept of being able to understand where a customer is in their shopping experience. You really don't want to be going to the cloud each and every time you want to recognize a customer that is staying inside of the store. So we're using Azure Stack Edge and some of the Azure Stack Edge concepts to do some of that cognitive service inside the store itself. In the future, we're going to figure out where that balance is. And that's something that we need to look at over time to figure out what the proper balance is between what do we want to run locally and what do we want to run in the cloud. Today, we send data up to the cloud at least once every 7 seconds.
Okay. Well, thank you so much, Henry, for giving us that overview and how you're using all of these products and services for your own solution. What would be that one thing that you would want to share with other customers or developers who are creating these solutions and applications with Windows 10 IoT Enterprise that you wish you knew or that you want to share out? What is the things that you think would be important to share with others?
So I think what Amelia was talking about before, taking the time to sit down and figure out what you want to have in your base operating system build. The key to making sure that this platform is easy to use, easy to deploy, easy to configure, is to strike a balance between what capabilities you've got built into Azure, so device provisioning, for example, versus what capabilities you want to have installed on the Windows IoT Enterprise build. I think that it's going to be different for each and every configuration, but I do think if you spend that extra week or 2 weeks making sure that you understand what those requirements are, run a nice proof of concept to make sure that you really are able to do what you think you want to do, you will save yourself a lot of headaches and a lot of confusion as you go out to your customer base.
That makes a lot of sense. Thanks, Henry and Amelia, for sharing that advice. So I really appreciate you being here. I appreciate Michael giving that overview of Windows IoT, answering the tough questions that developers had and really wanted to hear, and Amelia for giving amazing tech overview and a great insights or a sneak peek into the ARM64 support. So let's go ahead and jump into the resource slide to show how everyone could get started, and then how you can contact us after the event if you still have questions. Okay, so here are important links, and if you're scrambling trying to figure out, the URLs for all of these, don't worry. I'm going to put them in the description and also the description of the landing page and the YouTube as video as well. So for important links, if you're interested in kind of our different resources like the home page for Windows for IoT or windowsondevices.com, or just optimizing a Windows 10 IoT Enterprise image, we have those links available for you, jam-packed with great information. And then if you did not see what we did at Build, which Build is one of our top developer events, what we did was actually have a couple sessions that talked about Windows for IoT. So that Sam George announcement where he talked about virtual build spotlights, IoT updates and rollouts, that session, we have that linked here. That one's great because it showed, Sam goes over the full IoT Sam goes over the IoT portfolio when it comes to Microsoft. We also had the Windows for IoT team do a session about building your devices with Windows for IoT and talking about what is that, what are the tools, what are the things to know about for device developers. I'm going to go back a couple seconds. And then from the Windows team, they did a build session called Build Your IoT Devices for Windows for IoT. So check that out, especially if you're a device developer. That will give you a great deep dive of what's available and support it. Next, we talk about Azure IoT Edge on Windows and what that support looks like. And Terry from the Windows team gave that build session. So here's some more links about the Build conference on the Build site. All of these videos, again, are on demand. So if you didn't attend Build, you can see these. So we had Windows for IoT, a roadmap update. We had Linux modules on Windows 10 IoT Enterprise. And then we talked about ROS on Windows. So if you're into robotics and you're interested in what we're doing there, definitely check that out. And then if you are interested on the operations side with CI/CD, check out that one because it not only talks about ROS on Windows, but it talks about that Azure DevOps experience as well. And then all up, if you are part of our community for IoT, definitely check out these resources. One is that Microsoft IoT Tech community. This has been around for the last year, but we have all of these different conversational spaces. So we have one for Windows IoT and IoT devices. We have another one for Azure Sphere, for Azure RTOS. Then we have one for Azure IoT. But really, this is a location where you can share your projects, ask questions. You can see on the Windows one, a lot of people were asking about the Raspberry Pi questions that Michael answered. So it's a great way to share your projects and also hear the latest and greatest from the team. And then the Microsoft Q&A. So if you're familiar with Stack Overflow, which I imagine most developers were familiar with Stack Overflow, we do have a Microsoft Q&A. So if you're looking for technical help from our engineers, you can still go to Stack Overflow, but this is a direct way to get to our engineers by asking your technical questions on Q&A. And then we want to share a deep dive survey for 2020. So if you have a certain topic that you want highlighted, want us to deep dive on, maybe you want us to deep dive on maybe Azure RTOS ThreadX, let us know because we can go ahead and create these live events where we do training. And then also how you actually want to see that information. Do you want to see it completely online or completely live, or it's okay just to be on demand? So if you could fill out that survey, that would be amazing because we're always looking to improve the experience. All right, so I want to do one huge thank you again to Michael and Amelia and Henry for joining and taking the time to really help us understand what is the products and services when it comes to Windows for IoT. And I want to thank everyone who has joined, asked questions, and are viewing right now. So thanks, everyone. I hope everyone has a great day. Bye.